We're now asked here in these couple examples you can see at the top to solve each equation for y. And so in this first equation right here, you can see that y is occurring right there. So as I discussed earlier, there are some other terms on that same side that we're going to want to get rid of first before we deal with the 4y itself. So that other term that I just underlined in negative 3x, we're going to want to undo. So if you do just add 3x to undo the subtraction of 3x, then we know that 3x minus 3x will just equal 0. So you're going to get just 4y on that side. Then, of course, do the same thing to the other side to keep that equation balanced. We know that by commutativity of addition, right, that negative 6 plus 3x is the same thing as 3x minus 6. So we can write it like that. And then the last thing that we would want to do is then get rid of the 4, which we can do by undoing multiplication. And so one great way to do that is to divide by 4. Then every single term on that side is also going to have to get divided by 4 as well. So we're going to get just 1y because we know that 4 divided by 4 is just going to equal 1. And then right here, so you're going to divide that right there, and it's really just going to be 3/4 times x, and 3/4 can't be reduced. And then right there, that's a negative divided by a positive, which is going to be minus 6/4. But you're going to want to change that 6/4 because you know that's something that can be reduced, and we always want things simplest. So then you'd reduce that down to negative 3/2. And then that's going to be done because now you have the y alone on one side of the equation. In the other one right here, there's just the one single occurrence of y right there. So all of these other terms that you see right here, we're going to have to get to the other side. So since all of those three terms here are all positive, you're actually just going to have to subtract all of those terms to both sides. So really it just means you're going to get 9 minus 8/5 w minus 5x minus z all on that side. And then you're going to have negative, be careful about that, because that is a negative 3/4 right there, negative 3/4 times with y on that side. And so if now you want to get the y alone, you're going to have to undo the multiplication by negative 3/4, which you can do because if you do multiply by negative 4/3, then you're going to get positive 12 over positive 12, which just simplifies down to 1y. So what I did is I multiplied by negative 4/3, and that means that every single term on this side is also going to have to get multiplied by negative 4/3 to keep everything balanced. So we're going to have some distribution and such going on. So when I distribute right there, we're trying to take negative 4/3 and multiply that with 9, which really becomes negative 36 over 3. But we're going to be able to reduce that because negative 36 divided by 3 actually is just equal to negative 12. And then same thing right here. There we're going to want to do like a negative 4/3 times, and that's actually a negative 8/5. So you're going to get a positive 32 over 15. You're not going to be able to reduce that, so we'll just have to leave it as plus 32/15 w. And then you'll have to distribute to there as well. It'll be negative 4/3 times negative 5, which would be positive, and it's a 20 on top and a 3 on bottom, x. And then if it's just multiplying to that, that's a negative times a negative again, so you're going to get positive, but then, of course, it's just going to be 4/3 z. So that right there would be your final result solving that particular equation for y. Okay, and then jumping down to here now, we're asked to solve each equation now for x, and that will be what we're actually solving for the remainder of the examples here. So there's something interesting about this in that there's actually two different places where x is occurring right now. And so I actually want to solve this incorrectly, a wrong way, a way that you might think that you might be able to solve for this. So a wrong way to solve this is to think that, hey, maybe if I get the cx alone, then I could have f plus dx, because what I did to get from there to there is I just added dx to both sides, right? And then you think, okay, so now if I want to get this x alone, then I could just divide by c, because we know c divided by c is just 1. So then everything there gets divided by c, and so one way you could write that is it's going to be f over c plus d over c times x. And then, okay, right, then we got it solved for because there you got your x alone. but actually you didn't get it alone because x is still over on the other side, right? And so we kind of run into an issue with that. And so that's why that's wrong, right? If you're solving for a variable alone, like it's literally got to be alone. It can't be anywhere else in the formula. And so kind of one little trick that we can use to solve this here is to recognize that, okay, if I do have x on the same side, right, and one's cx minus dx, like we could just kind of use the distributive property, but sort of backwards. And what I mean by that is that you can just visualize that if you did have the quantity of c minus d times x, right, like you could think, okay, yeah, the x would distribute and be cx minus dx, right? That's the same thing as the left-hand side of the equation, right? So all I did right there is I just rewrote the left-hand side of the equation, right, to something that I know is still the same. And then really it's just, okay, I have c minus d that times us with x, and that equals f. And if I want to get x alone, I just need to undo this multiplication of the quantity of c minus d with x. So you just need to divide this side by the quantity of c minus d, and then that's going to cancel it out because c minus d divided by c minus d is just going to be 1. So you end up getting then just that f divided by c minus d, because of course you got to do that to the other side, will be your answer. So I've done this a few times before, but just make sure if you're going to write your answer more horizontally like that, that your c minus d is going to be in parentheses so that you have the correct order of operations stuff going on, okay? All right, the next one also has actually a couple places where x is happening because that's what we're trying to solve for. So if the x's, though, are on different sides like we've got going on right here, you're definitely going to want to get them on the same side somehow. So one way we could maybe do that is we could add x right there because that's just going to equal 0. And then we could add x to that side. So then we get m sub 2 is equal to m sub 1 times x. And then I guess I'll put the x right there because you can, so they're close to each other. So because we got a couple different places of x, then if we kind of try to, use that distributive property idea where we could like take out the x, but then think about, okay, what would that x actually distribute to, right? So it's going to have to distribute to m sub 1, but then to make it an x, this is actually going to have to be the number 1 right there, right? To be able to get an x right there. And so now what we have is we have this equation here just by kind of using that distributive property idea. And then now we can kind of work to get that x alone because that's really the only place where x is at. So before we deal with anything there though, right, there's that plus 4 that we're going to have to cancel out first because it's a separate term. So you're going to have to subtract 4 on both sides, meaning then that you're going to get the m sub 2 minus 4 is equal to the quantity of m sub 1 plus 1 there times with the x. And then finally, you can divide by that quantity of m sub 1 plus 1 to cancel that out there and get that x alone. And then, of course, do the same thing to the other side. So what we end up then getting as a final result for this one here is that x, when solved for alone, is going to give you m sub 2 minus 4 all over the quantity of m sub 1 plus 1 right there.